Welcome to Microsoft Build 2017. My name is Connor Wines, and I'm a program manager on the Windows Input Platform team working on the Surface Dial. I have a question for you. Are you a Surface Dial developer, or are you interested in developing for the Surface Dial? Maybe you're looking for ways to make your Surface Dial experience feel more natural, more intuitive, and really pop to the user. Let's take a journey into the way that we've changed the Surface Dial platform in the Windows Creators Update to make it better for both users and developers alike. So to start off, what is the Surface Dial? The Surface Dial is a brand new input device, a radial controller. It can be rotated to the left or right, and it can be clicked by the user. When I click on my Surface Dial, we can see that a menu will appear, giving me a range of options that I can select. For example, I've selected the volume tool. Now I can change the volume on my system to go down or to go up. When I use this with the Surface Studio, I also have an on-screen experience. I can place my Surface Dial on the screen, and the coordinate will be reported, and UI will be rendered around the Surface Dial, as opposed to in the middle of the screen, like you see on my Surface. What this allows us to do, from the Windows perspective, is deliver an experience that keeps creators in the flow of their content. Instead of moving their pen away from where they're drawing, moving their fingers away from the keyboard, they can just use the Surface Dial in their non-dominant hand to use some simple controls. And with muscle mastery, they can go ahead and create a lot of things very quickly. This gives them a lot more power. Now, the default integration that you saw, changing volume, scrolling, undo, redo, all of these things are provided for free by the Windows platform in every single application, whether that's a universal app or a Win32 app. However, we know the best experiences come when developers have the ability to customize and create an experience that's tailored for their application's needs. That can be achieved through the Radial Controller APIs. Now, the rest of this presentation is going to assume that you are somewhat familiar with the Radial Controller APIs. If you hadn't had a chance to look at those yet, please go ahead and look at the documentation on MSDN or some of our blog posts that cover how to develop for the Surface Dial. After this video is posted, I'll go ahead and post a link to these resources in the comment section below. So first off, I want to say thank you to all the developers out there who've tried the Surface Dial, and especially to those who've gone out and send some feedback to my team. Feedback from you is what makes us able to deliver a better experience in every single version of Windows. Thanks to the feedback we got from users and developers alike in the Creators Update, we were able to find ways to make the experience with Surface Dial better for everyone. I'll talk about some of the things we've done, but the big items here are giving users more access to hardware, giving them more power inside of Windows without necessarily needing to have specific dial integration, and of course, building the tools that developers need to build more intuitive and natural user experiences. So I mentioned that we have more hardware available. When we first launched the Surface Dial after the Windows Anniversary Update, it was only available in US markets. And we heard a lot of developer feedback that people said, hey, I would love to build an experience for this, but I don't live in the US. So we've done a little bit to help fix this. As of earlier in April, the Surface Dial was available for purchase in Australia, Canada, and New Zealand. And hopefully it will be coming to new markets soon. Additionally, when we talk about radial controller hardware, we're not just talking about the Surface Dial. We also have to talk about the Dell Canvas 27, which was launched at CES this past year. It's going to be released this summer, and it comes with a radial controller totem in the box, as well as touch and pen support. So any applications you write for the Surface Dial, you're also writing for the Dell Canvas 27. And then, if you're a hobbyist or a hacker, and you want to create your own radial controller, the hardware spec for radial controller devices is actually public on MSDN. So if you're interested in building one yourself, go ahead and try it out. I mentioned that we really wanted to give more power to users. And the way that we accomplished this was by giving them the ability to customize what the dial does in every single application. In the Anniversary Update, we had a tool called the Custom Keyboard Shortcut, where users could map keyboard commands to the left turn of the dial, the right turn of the dial, and the click. Users absolutely loved this feature. The only thing they wanted was more. They wanted to have more different custom keyboard shortcuts that they could build, and they wanted to create multiple custom keyboard shortcuts per app. So we added it. Now you can create a tool for each of your own applications, and users can create as many tools as they would like. This gives a Photoshop power user, for example, the ability to go in and map all of their favorite keyboard shortcuts to the dial and have their workflow be optimized specifically for their needs. Now, this is great. Keyboard shortcuts are definitely a plus, but we know what we want to deliver is a native experience, tailored to your application. So what we wanted to do was give the developers who work with Dial more control over the input that they receive from the dial and how they receive it, more control over the output that's shown when the user interacts with the dial, whether that's the haptic motor inside of the hardware or the menu that pops up when I press and hold on the dial. And then finally, we wanted to give more options for how to tailor the experience to your application's needs. I'll go into each of these new things that we added, show a little bit of demo code, and we'll do some demos along the way. First off, new interactions. We have two different input types on the dial that are really common for the way that you interact with it. There's a click and there's a rotate. And developers out there said, why can't we do both at the same time? So we've changed this to give more information about the dial's button state during all of your interactions. We have two new button events, pressed and released, that would be fired whenever the user presses down on the dial and then when they release. And afterwards, we'd fire the click event that's normally sent. Additionally, we now report the button state on all of our input events. So rotation and screen contact will have an argument that will tell you whether the button is pressed or not. So using this, you could build interactions like press or rotate, and you can also build an interaction like press and move with this new API. The Surface Dial hardware doesn't support it particularly well because it has a rubber on the bottom of it, but the Dell Canvas 27 does support press and move interactions. So taking a look at the code over here, you can see that on my radial controller instance, we have the two new event handlers, button pressed and button released, that you can register for. And much more common is looking at your rotation changed event and saying, under the arguments, is the button pressed? It's just a Boolean flag that returns either true or false. And when it's true, you can do something completely different. One thing that's very common is if you have, say, a list of different values that you can manipulate, have your normal rotation change the value, and have press and rotate switch between the values that you can manipulate. Other things that have been done is with something that can modify on two axes. Say you're moving an item that has an X and Y axis of movement. You can go ahead and switch where rotation would move you along the X axis and press and rotate would move you along the Y axis. So I mentioned input, let's talk about output. The Surface Dial hardware has a haptic feedback motor inside of it. In the Windows Anniversary Update, we did offer developers the ability to somewhat customize this experience. You could determine whether or not the haptics would be on or off, and then you could also set the angle of sensitivity for both the input and the haptics. So you could make it to where an input event and haptics would fire on rotation every 1 degree, every 10 degrees, or every 30 degrees, or anywhere in between. What we heard from feedback is that this wasn't sensitive enough for a lot of people's needs. They wanted to have an experience where they got input at 1 degree of sensitivity, but they only wanted to fire haptics sometimes under special conditions. So we added a new object to our input event args, the Simple Haptics Controller. This allows you to send feedback to the device using a new human interface device specification for simple haptics. Now we're really excited about this because having a specification for simple haptics means that we have the first step in a journey to a unified haptics story, not only for Surface Dial, but for gamepads and for vibration. So definitely check this out in the windows.devices.haptics namespace. So using this, you can customize how it feels to navigate your UI. Say you have a list of items and you only want it to vibrate when you hit the beginning or the end of the list so the user knows they can't turn anymore. Or if you have a slider that goes from 0 to 100, having it vibrate every 10 increments so that way the user knows kind of where they are without providing them too noisy of an experience as they rotate through that particular slider. Looking at the code over here, you can see that there is a Simple Haptics Controller. This one would have been obtained from your event arguments, just like the is button pressed flag in the example before. With this controller, I would go through and I would take a look at all of the feedbacks that it supports. A feedback is defined as the waveform, which is something like a click or a buzz, and then also a duration, how long it will take after you fire that waveform for it to finish. So I can go through and iterate through all of the feedbacks that are supported by my controller, find the one that's a click, and then send it back out to the device using the send haptic feedback function. There are other variations of this function as well, which will allow you to send a haptic feedback multiple times or with a specific gap between each sending. So you could have it click 3 times in a row with 500 milliseconds between each click if you wanted to. So when I talk about being able to tailor your experience, one thing that comes up is the icon that's used when you have a special item that you've added to the menu. With the Windows Anniversary Update, we had support only for a small set of known glyphs as well as PNGs. PNGs provided a little bit of difficulty. For a developer, you had to keep in mind high contrast mode, which would require creating a white icon with a small black background around it, so it would still be visible when high contrast mode got added. Additionally, if you had different DPIs that you cared about and you wanted to make sure that your icon always appeared crisp and there wasn't any artifacts due to downscaling, then you would have to manage multiple different icons. So we've added support for adding font characters directly to your menu items as the icon. This gives you better scaling with DPI since all font glyphs are a vector asset. It will allow automatic support for high contrast because all we have to do is change the font from white to black. And it's fewer resources for you to manage, especially if you already have a font installed with your application or you're using one of the fonts that are already installed on the system. And over here in the corner on my slide, you can see a couple of the icons that are already available in the Segoe MDL2 Assets font pack, which is already installed on the system. So taking a look at the code over here, if I wanted to take, say, the volume icon, which is always shown inside of the menu with Surface Dial, all I would do is create a font glyph. I would specify the name of that item as volume, specify the character that I'm using, in this case E767, which is a Unicode character, and then the name of the font family that's installed on my computer, Segoe MDL2 Assets. Now, if I wanted to use something a little more complicated, a little bit more custom for my scenario, I can bring in my own custom font. Say I have an airplane item which controls an airplane inside of my application. So I'm going to create a font glyph. This one I'm going to use with the name airplane. Let's say the Unicode character that corresponds to this glyph is F16A because my airplane is an F16. I'll specify my font family, airplane font, and since it's not one of the normal system fonts, I need to supply a URI which links to it. In this case, it's just a TrueType font which is inside of my app package. So with that, I can create my own custom icons using font glyphs. So let's take a look at a demo and see how this works end to end. So over here, I have a sample which I've used before in a previous Windows blog post that has an ink toolbar, which I can control this canvas with. I'm going to go over here, I'm going to create a yellow pen, and I'm going to do some inking. Now, in the Surface Dial menu, I have added a new icon, a new item. And what this does is it controls the background. It allows me to change the color of my background to complement my ink a little bit better. So I'm going to go ahead and I'm going to select this item, and I can go ahead and change the value of these sliders. Let's say I want something that complements very well with the yellow, so I'm going to make it a light baby blue. So I click over here, and I've applied this now to the background of my app. Now I can see a couple of ways that I can use these new APIs that I was talking about previously to make this experience a lot better. Right now, if I want to change these different sliders, I would have to go in, click one, change a value, click again to unselect, click a new slider, change the value, click again, and go back to the preview. Now I could probably make that a lot faster by using the press and turn interaction. Additionally, all of these sliders are very sensitive with a sensitivity of 1 degree. Right now there's no haptics. We could add haptics that happen on regular increments so the user knows that it's still working as they turn the dial without having to look at the UI associated with that slider. And then finally, over here in the menu, the icon that we use is one of the inbox known glyphs. In this case, it looks like a brush palette. I don't think that's a very accurate representation of my experience, so I'm going to use a font glyph to find an icon that works better for my needs. So if we go over to Visual Studio over here, we can take a look at this code running. Now the first thing you can see right off the bat is we're using this radial controller menu.create from known icon. I'm going to go in, I'm going to comment out this code, and I'm going to uncomment my create from font glyph. So using this, I've used the Segoe MDL2 assets pack, and I've also used an icon E7B5. Now, I can't show you what it looks like in this view, but we'll see it when we run the application. It looks like a rectangle with an arrow pointing at it, and I think that kind of represents my background. I like it, so I'm going to go with that. Moving forward in the code, we said we wanted to create a press and rotate interaction. Now, in this application, I have a state machine, which determines whether or not I have an item in that menu selected to where I'm changing a slider or if I'm navigating between the sliders. All I'm going to do is I'm going to change the behavior that happens here to, instead of checking if my item is selected to determine if I'm going to change the slider, I'm also going to check if the button is pressed. And if the button's pressed, I'm going to navigate between sliders instead of changing the value of the slider that's currently selected. That will accelerate my user experience, allowing users to very quickly change between different sliders. And then finally, over here, we can see that I have a function to create a haptic experience. So what I'm going to do is whenever I have a value on my slider that's a multiple of 16, or if it's 255, if it's all the way at the end, I'm going to go ahead and fire a simple haptic feedback. Now, I've created this function. It's exactly identical to what I showed in the slides earlier. All it does is it iterates through the feedbacks that are supported by the controller, finds one that has a click, and fires that feedback out to the device. So if we run this, we can very quickly see some changes in the user experience. The first thing that we're going to notice is the second that we open the menu with the Surface Dial, we're going to be able to see that it has a new icon. So I'm going to pop this open, and we can see our new icon over here, the background icon that I've picked from the Segoe MDL2 assets pack. And it's rendered very crisply because it's a vector asset and it always has the right color, although I'm not going to set high contrast mode now. It would be supported. So now when I select it, I can go in, I can change the color of my background, change the red value, and then without even taking my hand off the dial, I can go through and modify the green value, modify the red value again, get a light pink because I like that, and then apply it to the background. So there, I didn't even have to take my hand off the dial. I was able to do it all. And if we go ahead and look on the red slider over here, if you listen closely, you can hear the haptics that are going to fire every 16, and when I reach the end and the beginning of the list. So just by doing those couple of lines of code, we've been able to make our experience a lot more tailored for our needs. So let's go back to the presentation here. I'm going to talk about one new thing too, and that's customizing the menu experience entirely. So one thing that we heard in terms of feedback from developers is that menu popping up is not always a great experience. For example, say your application is a game or a full screen media player. If that menu pops up, it's going to get in the way of what the user is doing. You could imagine a user is watching their favorite movie and they press and hold on the dial. Now the menu is popped up and it's blocking their favorite character's face, or maybe it's blocking the dialogue on the subtitles. That's really not going to be a great experience. What we've done in the Creators Update is give you the ability to suppress the menu when you don't need it. Instead of press and hold opening up that menu, it will instead launch a new event called button holding, which will allow you to build a custom experience that's more tailored to your needs. Taking a quick look at the code over here is just a sample snippet. From our radial controller configuration, which is the global object where we set all of our system tools, whether we want that the zoom or the scroll or the volume tool, we can also now set two new properties. The first one is the active controller when the menu is suppressed. Because inside of my application, I might have several instances of the radial controller for whatever reason. We just need to pick one of them to receive all input whenever we're turning the menu off. And then secondly, we have the isMenuSuppressed Boolean. All this does is tell us whether or not we should fire the menu. You turn it to true, we won't fire the menu. Turn it to false, then the menu will appear as normal, and you can change that at will. Finally, there's a button holding event, which will fire whenever the user does a press and hold. So we're going to take a look at another demo here. I've built a very simple demo application, which is a media player. And in here, I have a video that's playing, and if I go in to my dial menu, I have two different functions that are supported. One is volume, changes the volume inside of my application. So if I go over here to the volume tab, you can see, it's changing the volume up and down. And if I go over here to my other control, it's playback. And so what that will do is it will start, stop my video and allow me to fast forward or rewind. Now, the tough part here is if I'm playing my video and I press and hold on the dial, that menu is going to pop up. Now that might be blocking the characters or the content. It's not the experience we want to deliver. So let's go into the code and see how we can make that a better experience. So opening up my code in Visual Studio, we're going to go ahead and make it to where whenever the video is playing, we're not going to pop open that menu. Instead, what we're going to do is automatically switch between the two tools. I know that I only have two tools, playback and volume, and I can just automatically swap to whichever one isn't active. So for the user, they'll feel a slight vibration, which I can give them during using the haptics API, and then they won't have to worry about any distracting UI pop-up. So going over here, I'm just going to uncomment some code. I'm going to set this active controller when the menu is suppressed to be the same radial controller instance that I use for handling the normal tool functionality, the volume item and the playback item. This ensures that I don't need to set new handlers. All the behavior will work as intended. Then I go in and I set my button holding event to be able to perform the action of switching between the two tools. And then because I want this to only happen when the media is playing, I'm going to add a current state changed event to my media player element. So looking at that current state changed event, all I'm going to do is double check if my media element is playing. If the media element is playing, I'll suppress the menu. If it's not, then I'll have the menu pop up as normal. On my button holding event, I'm going to go in and just switch between the two tools. I've created a small enumeration here, which I call mode. Every time the tool is selected, I'll update that mode. And what I'll do is say, if the current mode is playback mode, well, I'm going to go and I'm going to select the volume item. And if the current mode is my volume mode, I'm going to go in and I'm going to select the playback item to do the opposite of whatever the current mode is. And then when that occurs, I want the user to know that I've done something. So I'm going to send them a buzz feedback. We'll take a look at the code here because it's pretty cool. I'm going to use some of the additional features on the haptic feedback API. The flow for this is very similar to the last example, except instead of using send haptic feedback, I'm using send haptic feedback for play count. So here I'm finding the click waveform, and I'm sending it 3 times with a gap of 250 milliseconds in between. So now that all this code is ready to go, we'll give it a run. And we should see that once the video starts playing, I won't have the menu pop up, and instead it'll gracefully transition me over to the volume control. So I'm going to go here, I'm going to open the menu, navigate to my playback control. I'll click the dial to start the video. You can hear the sound playing. Here I press and hold on the dial. The menu didn't pop up, but I can still turn down the sound. So there we've created an experience that's really tailored to my application's needs. So going back to the presentation, I have one more item that I want to cover that we changed. For developers out there, especially UWP developers, performance is a really big issue. We want to make sure that our performance is always lightning fast, low latency, because if users see lag, they think there's a problem. So for UWP apps, this is a little bit difficult. You have to worry about the XAML UI thread. A lot of things happen on there, and if there are a lot of UI elements changing or a lot of long-running tasks occurring on the UI thread, it can be a bottleneck for your input. If you have a slider with very high sensitivity and something is slowing down the UI thread, the user might not be able to change it by increments of 1. They might see it changing by increments of 3 or 5 and get confused. So what we've done in the Creators Update is allow UWP applications to support radial controller input off of the UI thread. They can do this using the radial controller independent input source. If you've ever used the core independent input source for touch, pen, or mouse input, it operates almost exactly the same. Just taking a very quick overview of the sample code here, you would go and use the windows.ui.input.core.radial controller independent input source. You can go ahead and create a work item handler. Then you will create an independent input source for your application's core application view. Whenever you instantiate that independent input source, it does come with a radial controller already created for it, where you can set your handlers, do your input processing, and then set your work item to just process those events until you're done with it. And then using the dispatcher, you can obviously marshal things back to your UI thread if you need to update things that have occurred in your radial controller handling. So that's an overview of all the things we've added in the Creators Update. The first thing I want to say is if you thought any of this sample code was cool, you want to try it out, it should all be on GitHub today on Microsoft/Radial Controller repo. So go ahead and check that out. Additionally, if you have any questions, any feedback, if there's something that I didn't cover today or something you want covered in more depth, feel free to reach out to my team directly. Radialcontroller@Microsoft.com is a great resource if you have some technical questions that weren't addressed in our documentation and samples, or if you just have a great idea that you want to share with us. And then finally, we have a lot of other resources for you to learn more about Surface Dial, as well as the other elements of the Input and Windows Ink platforms. Please check out the Windows Ink talks that are available on Channel 9 today. There's also a Build Theater presentation by our friends at Silicon Benders, the makers of Sketchable, where they talk about their integration with the Surface Dial in the Creators Update. We also have some other great blog posts and Channel 9 videos. I'll be making a comment in the section below that has links to all of these resources for you. So thank you so much for your time, and try out the Surface Dial today.